So in this lesson, we're going to be looking at how to convert from a fraction into a decimal. So this is just literally the lesson plan I'm using tomorrow in class. So we want to convert fractions to decimals using estimation, and then the ratio table, the area model, and the partial quotient algorithm. Same thing we did when we were dividing decimals. Or it's similar to your long division algorithm. Obviously, we're not going to be using a calculator for this, but most of the time in real life, when I need to convert a fraction to a decimal, I just use a calculator. However, it's important that you kind of understand why. So we'll kind of start at the beginning here and move on. So the first thing we want to do is we want to estimate our problem so we kind of have an idea where our quotient could be. We know 15/64 is really 15 divided by 64. It's important that you have an understanding that this fraction bar is the same thing as division. A fraction is a divisional relationship, which really is also kind of like a multiplicative relationship in terms of what do you multiply the numerator by to get to the denominator is your quotient here. Not your quotient, but is maybe your unit rate, or what do you multiply the denominator by to get the numerator. We're looking at ratios. It's similar to that. It's all kind of connected, but it only comes down to this. I have a fraction, 15/64. I solve this problem, 15 divided by 64, and what does that equal? And ultimately, the estimate they came up with is 0.25, which is a quarter. And why do I think that works? Well, because I would say, okay, 15 times 4 would be 2 times 15 is 30, plus 30 is 60. So times 4 is going to be pretty close to 60. So that if it's 15 times 4 would be close to 60, then I'm thinking 64, 1/4 of it, or 0.25, would be what I multiply times 64 to get to 15. So 0.25 is a pretty safe estimate here. Now, we can use that to start coming up with our ratios in the ratio table. They start with 0.1 over here, and then you do 0.1 times 64, which is just moving the decimal point one spot to the left to get 6.4. And then they do the 0.2 because you have over here 0.2, so you have 2/10. So there's 2/10 times 64, which is just doubling your 6.4, you get 12.8. Now this is critical, as you then go back and you're going to do 1/100th, which is just moving your decimal point from your times 1/10, one spot to the left, and so you end up with 64/100th, 2/100th. You could have started with that one first, because just move your decimal point here, one spot, get 1.28, then add 64/100th, and you get to 3/100th. I would have probably gone all the way up to 5 here, just because it's 2/10 and 5/100ths. But you don't need that, because this is actually going to be a high estimate, and you actually end up needing this 3/100ths here. And then 4/100th, for good measure, would have been doubling the 2/100ths, and you get 2.56. And then it goes all the way even into thousandths, and from there you're just shifting your 4/100ths over one space, and you get 0.256. And then what we're going to be doing is we're going to be working here on the area model, and to do that, we basically set up this rectangle in 64, right, over here, and we do into 15. So the first time we put 64 in, we say they went and put in 2/10. That was the highest tenth value we had. So then you subtract 12.8, because this is close to 15. So then they do 15 minus 12.8, and you end up with 2.2. So you come back over to your ratio table, you say, oh, well, 2.56 is too high, so it has to be 1.92. So you put it in 3/100ths. So you have 2/10, 3/100ths, 2.20 minus 1.92, end up with 0.28 or 28/100ths. Come back over here, you don't have anything near 28/100ths, so you move over a decimal place, and if you actually just take your 4/100ths and move it over, so you're doing 4/1000ths, you end up with 0.256, which you can do 0.280 minus 0.256, and you end up with 0.024 left over. That's less than 2 cents in terms of money, and we're just always going to carry out to 3 decimal places. So in terms of a quotient here, we would end up saying our quotient would be about, we would say 15 divided by 64. This means about 0.15 2, 3, 4. Let me just take you through the last step, which is more like your traditional algorithm that you're probably used to seeing. For this one, you start out with 15 divided by 64, and you put the 64 in 2/10, which is 12.8. So you want to line up your places here. You subtract down, you end up with 2.2 left, so then they put it in the 300ths, which is 300ths times 64, which is what we did over on the ratio table, equals 1.92. And then we subtract that, you end up with 28 hundredths, and so 4 thousandths times 64 is 256 thousandths. This would be 28 hundredths is equal to 280 thousandths, so you do 280 thousandths minus 256 thousandths and end up with your 0.024 or 24 thousandths. This is kind of what you call like your remainder. We could continue to carry out the decimal places by adding zeros. We're not going to. We're going to go to 3 decimal places, add this up, and it's 0.234, just because we did one value in each place value. And so this is how you would divide using an algorithm, your numerator divided by your denominator to ultimately convert back to here. 15/16 would equal 0.234. This is an estimate here. Like, this is a very close estimate, so it's about that much in terms of a fraction, 15/64.